This video covers reading and writing R data files. The data and code used in this video are available on the Learning Management System. The data file that you will need is weather2017.rds. You should download the data and code prior to going through the video if you'd like to follow along. By the end of this video, you should understand how to load data from an RDS file into R, how you would save data from R into an RDS file, the types of information from R that you can save in an RDS file, how loading and saving RDS files integrate into your workflow, and when you should avoid using RDS files. So far, when we've been using R, we've either entered data by hand or used data sets that were built into R. Saving and loading your own data files is a critical part of the data science workflow. You're going to acquire data from original sources, you're going to save data and output from intermediate steps in your data processing and analysis workflow, and you'll also export data for other uses. One method of moving data around is the RDS file. These are R object files, and you use them to move data between R sessions. An RDS file contains a single R object, so think of it as a number, a vector, a tibble of data, anything that you can store in a variable. An important thing to remember is since RDS files contain a single item or object, you need to tell R what to do with it when you load it. And we'll work through an example of that in just a moment. RDS files are the preferred way to move data between R sessions. There's no loss of fidelity when you use RDS files to move information between R sessions because the loaded object is indistinguishable from the object that was used to create the file. They're also very high performance. They're stored in R's native format, so there's very low overhead in saving and writing those files. There are also some downsides to RDS files, and so they're not always the correct choice for storing information. Importantly, RDS files are specific to R. Only R can read and write RDS files, and so you don't use them to transfer data to other software. They're also bulky. They're an exact copy of the information that was in R, and sometimes you only want a portion of an object. For example, if you're saving a graph, you might only want to save an image of the graph as opposed to all of the data that underlies it. So given these advantages and disadvantages, when should you use RDS files? You'll generally use them for intermediate steps in your workflow. They're great for passing data, results, or other objects between your R scripts that do the various tasks in your workflow. Although you might want to consider other data formats if there's non-R steps in the intermediate steps in your workflow. You can also use these files to transfer data to other R users. I will frequently provide you data sets in the RDS format. It's fast and efficient if you know the person who is receiving the file will be using R. On the other end, when should you avoid using RDS files? You shouldn't use them for terminal points in your workflow. Generally, your source data is not going to be in RDS. It will be in some other data format. The output from your workflow should also be usable outside of R, so in general, the end tasks of your workflow should not use RDS files. You should avoid using RDS files for archiving data. You'd like your archived data to be in a more general format in case you would like to use different software to read those files later. Lastly, you should not use RDS files when you're transferring data to non-R users. This includes if you're trying to make data publicly available by putting it on a website. So, how are we going to deal with these RDS files? The tidyverse provides functions for saving and loading RDS files. The read RDS function takes a file name as its only argument, and it reads from the file and returns the contents. The write RDS function takes two arguments. The first argument is an R object, and the second is the path to a file, and it's going to write that object to the file name that you put in the file portion of the arguments. Both of these functions require the tidyverse library. There are base R versions of these functions that are more complicated to use. Those are the functions at the bottom of the slide here, the read RDS and save RDS functions. Because these functions are more complicated to use, you should generally avoid using them. So how do you go about loading an RDS file? The important thing to remember is that an RDS file contains a single object, so you need to tell R what to do with it. If you just use the read RDS function, it's going to read the file, and since you don't tell it what to do with it, it's just going to print it out to the console. Likewise, double-clicking an RDS file or dragging and dropping it generally won't work because you haven't told R what to do with it. So in general, you're going to pair the read RDS function with the assignment operator to store the object in a variable. So an example that I have here, I use the RDS function. I combine the directory where I store my data and the weather2017.rds file name with the file path function to create a file name. I then take that and use the assignment operator to put that information in the weather variable. What that's going to do is look for the file weather2017.rds, read it, pull the information stored inside of it out, and put it in the variable weather. You're going to create RDS files with the write RDS function. This function is a little different than read RDS. You'll specify the right RDS function. The first argument you give it is the object that you would like it to save to the disk, and then the second argument you give is the path to the file where you'd like it saved. So here I'm taking an object named weather, and I'm saving it to the folder specified by my sample data folder, followed by the file name myweather.rds. Again, this will take the object weather and write it to the file myweather.rds so I can load it again later. Let's work through loading and writing RDS files using RStudio. The first thing to remember is that read RDS and write RDS are part of the tidyverse. So before you run any code that uses those functions, you're going to need to load the tidyverse library. I have that at the start of my script, and we'll do that first. First, we're going to work through reading an RDS file. We'll load the file that I put on the learning management system, weather2017.rds. As is typical with all the scripts that I write, I put a file path statement at the beginning that points to the folder where I'd like to read and write my data from. So as you can see, I create a variable called sample data that includes the full path to the folder where I've written my data files. If you'll notice here in my Explorer window, I've copied the weather2017.rds file to a folder whose path matches what I've placed in R. You'll need to do this ahead of time if you'd like to replicate this code. But remember, you can use any folder you want as long as you set the information in that file path command correctly. Now that I've verified that this text actually points to the folder where I've saved the file that I would like to load, I can run that little bit of code, and you'll notice what R does is it creates a new variable called sample data, which just is some text that points to the directory name where I've saved the data. Now we can move on to actually attempting to load the RDS file. So again, here I have a read RDS command with the file path statement combining the path to the folder where I've saved the data and the actual name of the file that I would like to load. I can run this bit of code. And you can see what happens is a bunch of information is printed out in the output window. If you remember, read RDS reads the file and writes the output to the console unless you assign it to a variable. I didn't use the assignment operator, so all it has done is taken the contents of that RDS file and dumped it into the console. At this point, it's not very useful for me. So instead, I'd actually like to save that information to a variable called weather, and I'll do that here, just using the assignment operator with that same read RDS command. If I run that, you see there's no output in the console, but I now have a new variable defined under the data heading named weather, which contains that tibble. So what you'll notice here is that weather tibble has 365 observations and 6 variables. If we'd like to see what those variable names are, again, we can click the blue arrow in the Environment Explorer. It expands the information in that tibble to show me each variable name. Here we have month, day, year, minimum temp F, maximum temp F, and average temp F, and then some sample data for each of them. You could view the same information using the glimpse command. I can enter that here. And again, it shows me the names of every variable in the tibble, the data types, and some corresponding sample data from the tibble. Now that we've loaded some data in with the read RDS command, we could actually use that to write that data back to the disk to a different file. We can do that using the write RDS command. Remember, the write RDS command takes an object as the first argument. That's the information that will be written to the disk, and then it takes the path to a file as the second argument. So that is the command that I have here. I'll run that bit of text. R doesn't put any output in the output window other than repeating my command. But if you look at the folder that I showed you earlier, you'll now notice that there's a new file, myweather.rds, which is the file that I just wrote using that write RDS command. Remember that anything you can put in a variable in R can be saved as an RDS file. This will come in handy for other types of complicated information that we'll deal with later in the course. But here, just as an example, I'm going to save not a tibble, but a vector of numbers. So if you remember, I used the C function to create a vector. And what I'm going to do here is just create an arbitrary vector of a few numbers and save it in a variable called sum numbers. I can then use the write RDS function to write the information in that vector to a disk, and then I can load it again later. So I'll do that. Running that piece of code, R has now taken the information in sum numbers and written it to a file called mynumbers.rds. If I'd like to access that vector later, I can load it using the read RDS function. So now that we've created these two new RDS files, we can actually load each of them into new variables in our R session. So the first thing that I'm going to do is load that myweather.rds variable. Remember, that contains a tibble with the weather data that we saw earlier. I'll run that little bit. Again, there's no output in the console. It saves it to a variable called weather2. If we look in the Environment Explorer, you can see that it's created a new variable, weather.to, which contains the information that was saved in that myweather.rds file. We can take a quick look at the contents of that file using the glimpse function. If I run that, you'll notice again the variables that we're familiar with from the original weather file. We just saved a copy of it. They're all contained now in that variable weather.to, which was created from the myweather.rds file. We can do the same thing for the vector that I saved. Remember, that was in a file called mynumbers.rds. What I'm going to do is use the readRDS function to load that file and save the contents in numbers.to. Again, I run that bit of code, and if you take a look up in the Environment Explorer, there's a new value up there, numbers.to, which contains the same numbers that I put in that variable SUMNumbers earlier. Lastly, I can use the print function to print those numbers out in the console. Running print with numbers.to shows me those exact same numbers that I typed in before, 4, 8, 15, 16, 23, and 42. So again, readRDS and writeRDS are going to be important parts of your workflow. As you're moving data between individual R scripts, it's the ideal file format.